At the end of October 1917, the British Air Board made an interesting decision. The technical department approached the Phoenix Dynamo Manufacturing Company from the city of Bradford with a proposal to design and build 2 experimental flying boats. These were machines of the F3 model, with hulls to be constructed by another company, May, Hardin and May, which had a factory on the banks of the Thames in Hampton Wick. On the 12th of November came the official confirmation of the order from the Chief Inspector of Aircraft Supplies, Sir William Weir. And 3 days later, Phoenix received an expanded assignment. Now they were instructed not only to design specific components, but also to prepare for the production of complete aircraft. The company's engineers were given 2 primary tasks. First, they needed to improve the aerodynamic characteristics of the basic F3 model while keeping the root sections of the wing unchanged, so that the bracing system would remain interchangeable with the standard construction. Second, it was necessary to simplify the aircraft's overall structure to make it easier to manufacture. The contract was officially signed on the 28th of November, and the 2 flying boats were assigned serial numbers N86 and N87. Phoenix itself gave them the designation P.5. Interestingly, the name Cork was given to these machines only around June 1918, when the technical department issued a special instruction on aircraft nomenclature. Under this system, the Cork fell into the category of multi-engine aircraft with a total takeoff weight between 11,000 and 20,000 pounds, named after coastal towns of Scotland and Ireland. The P5 project itself emerged from the Admiralty's decision to build a large twin-engine flying boat that would meet the requirements of specification N3B. This specification had been formulated by the Admiralty's Air Department at the beginning of 1917. The British fleet needed a flying boat for anti-submarine patrols, something similar in characteristics to the Felixstowe flying boats designed by the port. But the Admiralty also decided that the new machine had to have a special hull design created by Lieutenant Commander Linton Hope. This officer was a well-known specialist in hull construction, and he was tasked with supplying the design to May, Hardin, and May, who were to build 2 hulls based on his monocoque principle. This type of construction proved exceptionally successful. Hope's hulls were strong, flexible, and had excellent streamlined shapes. The technology was rather complex. The hull was covered with 2 layers of narrow planking. The inner layer was laid diagonally and the outer layer lengthwise. These planks were riveted to numerous stringers, which in turn were attached to nearly circular frames. All of these frames were integrated into a keel running from bow to stern. The planing bottom was built separately but using a similar method. This construction made it possible to create a strong and reliable hull capable of withstanding the loads of takeoff and landing on water. At the end of 1917, Phoenix began producing the 2 hulls, which differed from each other. The first hull was most likely completed fairly quickly, by the 11th of April 1918. On that day, Major Miley from the technical department informed the company of the measured weight of the hull and the position of its center of gravity. The second hull was finished a little later. Both hulls had noticeable differences in their bottom design. The first hull's planing bottom extended all the way to the stern, although it was interrupted by the main step. The second hull's planing bottom had a forward step, and at the rear, a small streamlined secondary step was attached to the main hull. Its chine line was formed by a strip of outer planking that ran continuously from the upper part of the keel deck on the forward surface. It is interesting that the hulls were originally marked differently, yet they were eventually swapped when installed on the aircraft. Despite this, the basic construction of both hulls was identical. In the upper part of each of them were openings for the nose gunner, the 2 pilots who sat one behind the other, and the flight engineer. 2 narrow hatches were provided for the gunners, closed with removable doors fitted with glass portholes. At one stage, Linton Hope even planned to place the rear gunner in the upper section of the hull. Openings for the lower wing center section spars were also made in the upper side areas of the hull. The hull skin consisted of 2 layers of mahogany planking, with a layer of waterproof fabric laid between them for hydro insulation. The outer layer, with a thickness of 5/32 of an inch, was fixed lengthwise along the hull, while the inner layer, 5/16 of an inch thick, was laid diagonally. They were fastened with copper nails passing through square spruce battens measuring 3/8 of an inch, spaced 1 3/4 of an inch apart. The ends of these battens were inserted into an elm keel and secured by 35 spruce stringers measuring 1 1/2 by 1/2 of an inch. evenly distributed around the hull perimeter. The stringers were attached to nearly circular frames placed every 2 to 3 feet. The frames were mounted directly onto the upper part of the keel. A pair of curved elm beams with a rectangular cross-section were alternately joined with dovetail joints to the upper and lower parts of the hull. The lower hull section was reinforced with short, square-section spruce slats running across the keel. These were known as floors. The forward planing surface of each hull had 2 separate layers of mahogany divided by waterproof fabric. The inner diagonal skin was 3/32 of an inch thick, and the outer skin was 3/16 of an inch thick. The fastening method was similar to that used on the main hull, but with plywood transverse bulkheads forming a series of watertight compartments. The aft planing surface of the first hull was built in a similar manner. The outer and inner skins were 5/64 of an inch and 5/32 of an inch thick, respectively. The planing surface of the second hull was slightly larger than the fairing of the rear step and was also designed by Linton Hope. The first hull was delivered by road from Hampton Wick to Bradford shortly before the end of April 1918. Soon after, the second hull was dispatched. It traveled north on Wednesday, the 8th of May. Records show that the total production time for both hulls amounted to 31,348 man-hours. On the 9th of April, the company Hardin and May delivered wooden models of the flying boat hulls. They had been produced under contract and handed directly to Linton Hope of the technical department. These models were made at the National Physical Laboratory specifically for wind tunnel testing. The results of these tests were later published in a scientific report. During the research, something interesting emerged. The first hull design had significantly lower aerodynamic drag at all speeds compared to the second version. An improved version of the first hull was also tested, in which the keel deck was joined to the main hull by means of concave joints. It turned out that this modified version also had less drag than the second hull, and even slightly better performance than the original version. Despite the superior aerodynamic qualities of the first hull, which should theoretically have improved the overall capabilities of the completed flying boat, upon arrival in Bradford it was sent into storage. Instead, the second hull version was used for further work. The reason for this decision remains unclear, but it is likely connected to events of November 1916. At that time, a scientific publication was released titled Experiments with Models of Seaplane Floats, 11th Series. The report described in detail the hydrodynamic tests carried out at the laboratory on hull models submitted by Linton Hope. These models resembled the first hull version. Various changes were made to the hull, and its shape began to resemble the second variant. It turned out that this hull had better seafaring qualities. The reason was that the side waves created by the front part of the planing bottom moved differently, and the characteristic fan-shaped splashes appeared much closer to the stern. Previously, the strong splashes produced by the forward part of the planing bottom reached the upper section of the hull, and the side waves tended to curl over the rear part of the hull, which led to wetting and damage to the wings and the tail unit if they were mounted too low. It seems that the first version of the hull was abandoned in favor of the second because of its poorer seafaring qualities. There is an assumption that the first hull was built for comparative full-scale testing. In the spring of 1918 in Bradford, the aircraft components designed by William Manning were almost ready. These structures were created under the supervision of the technical department, which examined and approved Manning's calculations and, when necessary, provided its own recommendations. Information about the state of the structure appeared on the 11th of March 1918. Solly Brandt from the Structures and Stability Section reported to the inspector of the technical department, Commander Alec Ogilvie, that the strength of the wing spars, the interplane struts, and the bracing wires had been deemed satisfactory. The only exception concerned several not fully completed control linkages. According to the policy of the Phoenix Company, described in the book Women in the Production of War Material by Managing Director Philip Phoebus, all structural elements were designed so that women's labor could be used. This was an initiative of Prime Minister Lloyd George. Women's labor was to be applied wherever possible. This policy was applied to the production of both wooden and metal components. As for the latter, finished components were minimized, and others were designed with mass production in mind. The dimensions of the fittings and bolts were standardized so that most of them could be easily replaced. This made it possible to reduce the diversity of stock supplies. The aircraft's wings had different spans and were made as separate parts. The upper wing consisted of 3 sections. Its outer parts were attached using special streamlined struts positioned above the main interplane connections. The lower wing was more complex. It had 4 parts. 2 of them formed the central section, whose spars passed directly through the aircraft's hull on one of the models. On another version, the wing was a single unit attached directly to the upper part of the hull, and the joints were covered with special fairings. Each wing had 2 main spars, load-bearing, box-shaped beams. They were made entirely of spruce. The spar sections were connected with compression struts and flanges using screws and glue. To reduce wear, the flanges could be made of several short pieces joined together, although their number was strictly controlled. The wing ribs, transverse structural members, had an aerodynamic profile and a truss-like design. They were made of spruce strips, but the attachment points to the wings were cut from plywood. Elongated openings were made in this plywood to lighten the structure. The leading edge of the lower wing was covered with 3-ply birch plywood to protect it from water spray damage. On the central section of the lower wing, there were walking platforms. The flight engineer used them to start and service the engines. The internal wing attachments were made using bracing wires and tubular steel struts. The ends of these struts were inserted into special sockets at the spar joints. The struts between the wings and the engine struts were made of thin-walled steel tubes. Their heavily loaded ends were attached to the hinge joints with rivets. To make the struts more streamlined, they were covered with wooden frames with 3-ply plywood at the front and fabric covering. On the spars, at the mounting points of all struts and external bracing wires, reinforcement pads made of mahogany or walnut were installed. On the 5th of July 1918, the technical department received a report stating that the construction of the first aircraft had been completed, and permission was requested to transport the flying boat to the town of Breux, at the mouth of the River Humber. Exactly 1 week later, another letter was sent, reporting that the second aircraft would be ready for dispatch in the near future. The following day, the permission was granted, and soon the first aircraft was sent on its way to Breux. However, some parts, including various tailplane struts and the engine cowlings, were shipped by rail. The transportation took place on the 26th and 27th of July. Before the completion of the first aircraft, the Phoenix Company requested that pilot Clifford B. Prodger be involved for the initial test flights. On the 4th of July, the technical department agreed on the condition that the subsequent test flights would be carried out by Major M.E.A. Wright. The first flight of the aircraft, which was named Cork Mark I, took place on Sunday, the 4th of August 1918, between 6:20 and 6:30 in the morning. Prodger sat at the controls, accompanied by representatives of the Admiralty, Lieutenant Commander Hum, and Captain Slater, who served as the flight engineer. By 8 o'clock in the morning, they had completed 2 more flights. The first lasted 8 minutes, and the second lasted 28 minutes. The weather was excellent, with a gentle northeasterly wind that was barely noticeable. Prodger said the aircraft performed very well. He did note, however, that the nose felt slightly heavy and the rudder was too small. Because of this, he did not attempt to accelerate the aircraft to its maximum speed. After the tests, the aircraft was moored overnight to the shore of the estuary, but the next morning, at 5:30, it broke free. Between these flights and the next test, which took place in the evening of the 9th of August, it was discovered that the wing covering had stretched slightly. However, this seemed to have almost no effect on the trials. Once again, the aircraft was described as a machine with excellent characteristics. A new enlarged rudder was installed on the aircraft, and a fully loaded test flight was carried out, lasting 54 minutes. Prodger was again at the controls, accompanied by Hum, Slater, and an engineer from the Rolls-Royce company named Finch. The trials were observed by Majors Maurice Wright and Miley, who took the controls themselves the following morning, with one of them sitting in the cabin as a passenger. This test flight began at 11:08, after some difficulty starting the engines, and lasted 12 minutes. Due to an engine malfunction, another flight was arranged later the same day, but once again the engines took a long time to start. By 4 o'clock in the afternoon, everything was ready, but the tide had gone out. They nevertheless decided to proceed with the tests. Unfortunately, as the aircraft gained speed and rose onto the step, it struck a rock and began to sink. The landing was ultimately completed, but the aircraft was half filled with water. The crew tried to restart the engines, which had stopped immediately after the impact. They succeeded and managed to taxi the flying boat to the shore and beach it on the mud. By that time, it was already 7:30 in the evening. The rescue operation could not be carried out the following day because another flying boat, the Phoenix F-3, was scheduled for flight testing and there was no time to supervise the damaged aircraft. However, the next morning the hull was repaired and the aircraft was pulled ashore. After repairs, on the 24th of August 1918, it was flown by Major Wright from the Experimental Naval Air Station on Grain Island. The aircraft underwent a final inspection on the Isle of Grain the next day, and during the following week it was tested in the air to obtain preliminary data on controllability, climb rate, and speed. This was officially reported in the document dated 31st of August 1918. Among the design shortcomings noted in the report was insufficient rigidity of the wing covering. The cockpit layout was also criticized. The arrangement of the crew positions, the instruments, and the throttle control. It was considered worse than the pair of separate levers that could be operated with one hand, a method that felt more natural and familiar to pilots. However, the criticism proved unfounded, because shortly after the fuselages were delivered to Bradford, mock-ups of the cockpits were built there using one of the fuselages, and their layout was officially approved. The report went on to state, the aircraft proved easy in lateral control, and its overall controllability was adequate. It recovered from a bank quite easily. The rudder could have been slightly larger with better balancing and a more powerful linkage. The elevator operated smoothly and effectively. The aircraft had a somewhat heavy nose. On the water, the flying boat behaved very steadily during takeoff and landing, with no tendency to bounce. During taxiing, a considerable amount of water reached the propellers, and the bombs were splashed by the water thrown up by the keel of the forward part of the hull, although it was not a continuous sheet of water. The aircraft took off and landed somewhat awkwardly. Apart from the spray on the propellers, getting off the water was very good, and the landing was soft and free of shocks. The investigation into the cause of the wing's insufficient rigidity showed that the wrong type of dope had been used for the fabric. Since the second aircraft was at that time in production, its wings were treated with different dopes, and it was decided to use them to replace the wings on the first aircraft. The replacement was carried out in October 1918, and the old wings were sent back to Bradford for retreatment of the fabric and installation on the second aircraft. From the preliminary tests, it was clear that the wings of the first aircraft had been installed too low relative to the fuselage. It was likely for this reason that the wings from the second aircraft were mounted on the upper part of the fuselage, and the openings in the fuselage for the spars were plugged. Testing of the first aircraft resumed in October after the installation of the new set of wings. On the 17th of October, a test report was published covering the trials conducted on the Isle of Grain, comparing the first aircraft with the Felixstowe F-5 prototype in terms of cockpit visibility, instrument placement, crew arrangement, controllability, and takeoff and landing performance. Apart from the instrument placement and the arrangement of the crew members, which were rated as worse than those of the Cork, there were few differences between the two models. The author of the report may have mentioned, though in fairness, he likely did not request that it be recorded, that the P-5 surpassed the F-5 in such operational characteristics as speed, climb rate, and range, and could carry a greater useful load. The report also noted that the P-5 had not yet been tested in rough seas, and that the main step had once already been damaged, possibly due to deformation caused by the launching trolley. Another report followed on the 22nd of October concerning the rudder of the first aircraft. Evidently, this resulted in the installation of the fairings recommended in the previous report. Overload tests were conducted, the results of which were included in the report dated the 10th of May 1920. Later, the first aircraft was fitted with navigation lights. Subsequently, this aircraft was used for experimental work on the Isle of Grain, and it is known that it flew until the end of 1924, when it became the subject of impact load tests described in the corresponding report. Production and assembly of the second aircraft, which became known as the Cork Mark II, began in late August 1918. On the 24th of September, the company Phoenix was informed by the technical department about the need to introduce major changes to the hull. Fortunately, at that time only the center section of the lower wing and the fin had been installed on the hull, and whether they were removed during the hull modification remains unknown. The changes were made according to the drawings of the Air Force Committee. The proposed P-5 hull contours were produced by the shipbuilders of the company May, Hardin, and May between the 15th of October and the 2nd of November. The resulting hull resembled the fuselage of the first aircraft but had an aft step positioned closer to the tail. Afterward, the assembly of the aircraft continued steadily, and by the 25th of November, the central section of the wing without engines and the completed stabilizer had been installed. But then a new delay occurred. It turned out that the wrong type of aircraft dope had been used to cover the wings. Eventually, on the 21st of February 1919, the second version of the aircraft was sent on its way to Brau for final assembly. The first flight took place on Friday, the 28th of March in the afternoon, and lasted only 7 minutes because of strong winds. The crew consisted of the pilots, Majors Wright and Miley, as well as Chief Petty Officer Dryden, Chanette from the Rolls-Royce Company, West from the Phoenix Company, and the engineer Edwards. Because of storms and heavy sea swell, it was impossible to pull the aircraft ashore, and during the attempts, a strut tube of the stabilizer was damaged. The aircraft remained tied to a buoy until the following Sunday evening, when they made sure that the boat had not been flooded. They noted that the Cork handled storms well, and the Phoenix Company actively used this fact, comparing the aircraft to its namesake, a cork. Despite the bad weather, the tests were successful. Takeoff occurred automatically, and controllability and stability, in Major Wright's opinion, were excellent. The aircraft climbed energetically at a speed of 80 miles per hour with a headwind of 25 miles per hour. However, criticism was expressed regarding the gasoline pumps and valves. The former delivered fuel too slowly, and the latter were dangerously positioned between the chain that connected the pump to its windmill. Maintenance recommendations were given. In particular, the towing ring was placed at the stern for attaching the cable, to minimize damage to the stabilizer's strut tubes from its movement. Naturally, test flights were carried out again, although they were apparently interrupted once more when the wing covering was replaced yet again. For this work, the Phoenix Company received a contract dated the 24th of May, 1919. In June, on the Isle of Grain, the aircraft was piloted by Major Wright, and from then on it was used for experiments. In December 1919, the bottom of the aircraft was badly damaged when, in bad weather, it was brought ashore on a launching trolley. Repairs began and were completed in early 1920. One of the results of this accident was the invention of a trolley that used fabric tanks filled with water as a resilient cushion for the hull. In the summer of 1922, a decision was made to install 2 Napier Lion engines with a power of 450 horsepower. Trial assembly of the uncowled engines and their installation on struts with modified fittings was carried out in Bradford. After this, the engines and structures were delivered to the Isle of Grain and installed on the aircraft, which was then renamed as the third version. On the 2nd of August 1922, the first flight with the new engines took place. It lasted 10 minutes, piloted by Flight Lieutenant George E. Livick. That day, the aircraft, at the start of its flight from the Isle of Grain to the Scilly Isles, was supposed to join the experimental flying boat unit. The flight was delayed due to a malfunction in the fuel system. Flight Lieutenant, later Group Captain of the Royal Air Force, recipient of the Distinguished Flying Cross and the Air Force Cross, George E. Livick recalled this. "We had a system made by hand, created, I think, not by the company's designers, but on the Isle of Grain itself. When you turned on the fuel supply, the fuel went not into the engines but into the hull. Before the flight, we had to pump out a little fuel and clear the pipe. On the 4th of August, the aircraft joined the long-distance flight of the Experimental Aviation Detachment from Spithead. The main purpose of this flight was to gain experience in operating flying boats far from their home stations, using ships as their base. The unit consisted of several different flying boats accompanied by an aircraft carrier, a seaplane tender, a destroyer, and a floating dock of the Royal Air Force. Several experienced pilots were assigned to the flying boats. On the 31st of October 1922, the commander of the detachment submitted a final report and recommendations on flight training to the leadership of the Experimental Marine Aviation Center. The report contained detailed evaluations of the characteristics of each flying boat and of the rest of the unit. A comparison of different aircraft types was conducted, and it was concluded that the tested aircraft was better than the other models and significantly outperformed its competitors. The conclusions took into account the condition of each machine at the beginning of the flight, and this particular aircraft had been in the worst condition. The report included comments from the pilots regarding the characteristics and shortcomings of their machines. Here is what one of the pilots wrote. "No data are provided except for the takeoff time, which in calm weather with a full load averaged 24 seconds. The airspeed indicator was functioning incorrectly, making it difficult to assess the full speed accurately, which was approximately 101 to 104 miles per hour. The best cruising speed was about 78 miles per hour, and the leading speed was approximately the same as that of the competitor. Handling in the air is excellent, with the exception of aileron control, which seemed slightly insufficient, especially at very low speeds during landing at the critical angle of attack and during takeoff. Rudder and elevator control are very good. On an aircraft of this type, on Oxtla and Nuster Muahane's long-distance flights are much more pleasant than on the competitor. Flying it is not as exhausting for the pilots. There is a sharply pronounced snatching of the elevator control rods when the number of engine revolutions changes in the air. This may be connected to tail oscillations caused by lateral flexing of the hull. At low speeds, the machine is very controllable on the water, but sea anchors are required except in very strong winds, as in such conditions the aircraft moves across the water too quickly even with the engines completely shut down. High-speed handling, for example, during takeoff is good, and the tendency to bounce can be easily controlled with the elevators. The difficulty during takeoff lay in the danger of submerging the wingtip into the water. The wingtip floats were so low that any tendency of the machine toward a lateral turn had to be countered quickly, otherwise it could lead to wing damage. This makes takeoff in a crosswind particularly difficult. When taxiing occurs in a crosswind at any speed, the underwing float easily dips into the water and water washes over the lower wing. Apart from this, during taxiing, the machine is very clean, almost without spray, and unlike the competitor, it does not produce as much noise. The seaworthiness of this machine was thoroughly tested in 6 storms, which it withstood without any damage, unlike the others, especially in the open sea near the Scilly Islands. It is interesting to note that one 4.6 storm, which lasted for 24 hours, was successfully endured without the rear side doors properly installed. The machine took in a small amount of water, clearly insufficient to put it in danger. However, it should be considered that some water entered through these doors when the boat taxied into the wind or made a rapid turn on the water. By the end of the long-distance flight, it had become unmistakably clear that the aircraft was performing worse. It was harder to lift into the air, its handling had deteriorated, and controlling it required much more effort. Several factors contributed to this decline. The hull had become saturated with water, moisture constantly seeped through the outer skin, and the pump could not remove it. The fabric covering of the surfaces had begun to sag, and even at the beginning of the journey, it was evident that the material was old and rotten. And overall, the aircraft's characteristics had worsened for a variety of reasons. Summarizing all of this, it was concluded that this type of aircraft, with several small modifications recommended in the report, could be significantly better than the current model in almost every respect. Later, Colonel Levesque recounted the final days of this aircraft. He said, "The last flight on the 18th of September 1922 from Portland was extremely unpleasant. I managed to get the aircraft out of the water only after many miles of taxiing. In the air, it behaved terribly because a great amount of water had entered the step compartment. When passing New Haven, I intended to make an emergency landing due to the failure of the exhaust manifold. The flame from the exhaust gases was striking directly at the magneto. After a temporary repair, I attempted another takeoff, but given the poor condition of the machine and the heavy jolts from the wave crests, this was clearly unwise. So I taxied into the harbor at New Haven and moored at the pier. That night a storm began, and either the pier drifted away or it broke apart, causing the aircraft to crash into the wharf. The machine was then towed to the harbor dock, where it was taken in. They attempted to dismantle it on the water, but the boat listed and sank. In the end, the aircraft was recovered from the water in pieces, loaded onto a trailer, and transported back to the Isle of Grain. The aircraft had attracted interest in many countries. Among them were the American Aviation Mission in August 1918 and the company Boulton and Paul, which in December 1919 received drawings of the hull to train on converting steel and wooden structures. The company Phoenix Dynamo considered a civilian version of the aircraft, one designed to carry 10 passengers or an equivalent cargo load. Manning also explored the possibility of taking part in the first non-stop transatlantic flight proposed by the Daily Mail, which offered a prize of £10,000. His calculations suggested that the aircraft could have completed such a flight with ease. The further development of this design became the English electric Kingston flying boat, equipped with Napier Lion engines.